Hello there, and welcome back to another edition of Magazine Magic Math Movies, where you get to play the role of the therapist and solve all of math's problems. Today we are going to cover Chapter 4, Lesson 3, Linear Function Patterns. It's on page 164 in your blue Big Ideas math book. So turn there now and we'll get started. We have one term here that we need to know for this lesson, and that is what a linear function is. And all it is that it's a function that when you graph it, all the points will be in a straight line. So an easy way to remember that is that in the word linear is the word line. Okay, that's all it means, is linear is line. So whenever you graph the points of a function, if they lay in a straight line, if they all line up and you can draw a line through all of them, then it's a linear function. Alright, here you'll see a picture of what's in your book. This is example number 1. And it wants us to use this graph that I have taken a picture of and put in this video to write a linear function that relates y to x. So we're going to have to write a linear function in function form where y is all by itself and how it relates to x. You can see that this is a linear function because all the points are in a line. Okay? You could draw a straight line through these 4 points, so we know that it's a linear function. Alright? So to write a linear function that relates y to x, we're going to follow a few steps. Okay? We need to do, first, we need to find the slope. Okay? And you may or may not remember this. Hopefully you do, because you've been using it a lot. Slope is the same as rise over run. So in order to find this, we need to pick 2 points. Alright? Doesn't matter what 2 points because you're on a line. So you can pick this one and this one, this one and this one. It doesn't matter. I wouldn't skip points. I would go from this point to that point, or from that point to that point. That way you don't have to do any reducing. But just for here, let's choose 0, -3, and 2, 0. Okay? We're going to find our slope. So we're going to work our way from left to right, and because we read left to right, from left to right, this graph goes up. So we know that our slope should be positive, because from left to right we're going uphill, so we're positive. Okay? So what I'm going to be doing is from here, from this point, 0, -3, what is my rise? How many do I have to go up to get level with the point 2, 0? I have to go up 1, 2, 3. So the rise portion of my slope is 3. And now I need to find the run portion. Okay? So if I go up 3, how far do I have to run to get to this point? I have to run 1, 2. So my run is 2. I've found the slope now of this linear equation. The second thing that I have to do is I have to find the y-intercept. Okay? And remember, the y-intercept is wherever that line crosses the y-axis. Okay? So here we have an imaginary line going through all these 4 points. And remember, the y-axis is the one that goes up and down. So where does this line cross the y-axis? Right here. Okay? This line crosses the y-axis at this point. Okay? That point is at -3. So our y-intercept is equal to negative 3. Now all I have to do is to write it in function form. And to do that, it's y, okay, equals. Then we have our slope. Okay, and then our x. And then since our y-intercept is negative 3, it's minus 3. And then I'm done. Okay? That's my answer. So I've taken this graph, and from the information I have in this graph, I have found first the slope from one point to the other. Second, I found the y-intercept. And then I've put it in an equation, slope-intercept form. Alright, now example number 2. It wants you to do the same thing, but this time instead of giving you the graph, they give you a table. Okay? So they would give you this right here. They would give you all the x's, and they would give you all the y's, and that would be it. So in this case, your first step would be to graph these points. Okay? Which I've already included a picture of it that's in your book. So here we have negative 3, 9. So negative 3, 9. Negative 2, 7. Negative 2, 7. Negative 1, 5. Negative 1, 5. And 0, 3. 0, 3. Okay, so I've taken a picture of step 1. Okay, which is to graph. And now step 2 or 3 are going to be the same like we did before. 2 is we're going to find the slope. Okay, so we're going to choose 2 points and find out what our rise and run is between these 2 points. Okay, now I've noticed that my graph from left to right is going down. So that means that my slope is going to be negative. Okay, so I know my slope has to be negative, and I'm also going to check my scale, and it looks like I'm counting by ones, so there's no tricks there. And so now I'm just going to pick 2 points. It doesn't matter what 2 points. I'm going to choose this point here and this point here. Remember that slope is rise over run. So how do I get from this point to this point working left to right? Well, rise, I have to go down 1, 2. Okay, so since I have to go down, it's going to be negative 2. And my run, how far do I have to run? It's going to be down 2, and I have to run 1 to the right, and so that's going to be a positive 1. So that's my slope. My third step, recall, is to find the y-intercept. Okay? Where does this line cross the y-axis? Alright, well, let's take a look. Here's the y-axis. Where is the line going to cross that y-axis? It's going to cross right here at this point. So what y value is that? That's 3. And so my y-intercept is equal to 3. Now all I need to do is I need to write this in slope-intercept form where everything relates to y. So y is equal to the slope, which is negative 2, then your x, and then our y-intercept is going to be plus 3 because we're above the x-axis. Okay, so my answer is y equals negative 2x plus 3. Alright, this one here is an example that's in your book. This is example number 1. You need to use the graph in order to write the linear function that relates y to x. So you're going through the same steps that, that we did. So pause the video, see if you can figure this out. Alright, let's see how you did here. Since this is already a graph, we don't need to put it into a graph. If it was a table, we would. So what we need to do is we need to find the slope. And I'm going to pick 2 points. And I'm going to find out the slope what it is. Remember, it's rise over run. Okay. So let's see. It's going down from left to right. I can see that pretty easily, down left to right. So I know that my slope is going to have to be negative. If I get a slope that's not negative, I did something wrong. Okay. So I'm going to go from this point here to this point here. And my rise, since it's rise over run, has got to be down 1 until I'm level with that point. So my rise is down 1, and my run is 2. So that's my slope. The second thing that I need to find is the y-intercept, and that is where the line crosses the y-axis, and in this particular graph, that it crosses the y-axis at -1. It's going to cross right here where y is -1. Okay, so that's my y-intercept. Now all I need to do is write it in slope-intercept form, and I should get y equals a negative, my slope, -1/2, don't forget your x, minus 1. And that should be your answer to number 1. Alright, here's example number 3. And example number 3 is a little bit more involved. There's more steps that we want to make sure that we answer each and every single one of them so we don't get marked off and forget something. Alright, so in your book you'll see on page 165 that this chart is off to the left of the page and this is off to the right. Okay, so in your book it says graph the data in the table. So what it would want you to do, step 1, it would want you to take this, and it tells you that the hours kayaking is the x and the calories burned is the y, and it would want you to put that on a graph. Well, since this is the example, they do that for you, and this is what I've done here. I've taken a picture and put the same graph over here. So if you were to do this on your own, you would get the very same graph that would look like this. Hours kayaking is your x, so hours down here, and the calories burned is your y, so the calories burned goes up the side. And you need to find out your scale. So they have 2, 4, 6, 8. They do even hours, but on the graph they decide to put 1, 2, 3, 4. They go by ones. And then because you're dealing with calories that go up into the thousands, we need a little bit different scale. So they choose a scale of 300. So each interval is 300 goes up by 300 calories. So they go from 0 calories all the way up to 2,400. And then they graph the points. So at 2 hours you burn 600 calories. You'll see that here. At 4 hours you burn 1,200 calories. They graph that point. At 6 hours you burn 1,800 calories. And at 8 hours of kayaking all day, you burn 2,400 calories. Okay? And the very first part that they want you to answer is the domain discrete or is it continuous? Is the domain 2, 4, 6, 8 the only values that would make sense? Is it discrete? Your answer should be no. Because you can kayak for 1 hour, you can kayak for 30 minutes, you could kayak for an hour and a half, or any time in between there. Okay? So this should be a continuous domain, which means that you need to connect all your points of the line. Part B says that you want to write a linear function that relates y to x. So here's where we're going to have to jump in, do some work, and put to use what we learned in the last couple of slides. So to write a linear function that relates y to x, we're going to be using this graph, and we're going to be doing the same thing that we were doing. First thing is we need to find the slope. So the slope of this line. Okay, let me right there. I'm going to go from this point right here to this point right here. Okay? Now I need to be careful on your rise. Alright? We're going left to right, so it's going to be positive, but be very careful on your rise. Here's the trick. Here's what you got to watch out for. How many jumps are you going up? 1, 2. But your rise isn't 2. Okay? You're going up 2 lines for sure. But how many are you really going up? How many lines little lines that are invisible, did you skip? Okay? You're really going up how many? 600. Okay? So our rise is 600. And our run is what? Okay, now if we're going to go here and we're running over to this point, our intervals are just 1, so our run in this case is 1, 2. Okay, no tricks there. So our run is 2. Now to simplify this, to get our slope, we just need to divide 600 divided by 2, and that gives us 300 over 1, or you can just leave it as 300. You don't need the 1 underneath. Okay? The other point is to find, remember, our y-intercept. Okay? Where does this line cross the y-axis? Okay? This line crosses the y-axis at, you can see it right there, 0. So our y-intercept is 0. Now we just need to write our equation. Okay? Y is equal to 300x, because that's our slope, plus 0. We don't even need to write that 0. That's going to be the same thing as y equals 300x, just like that. Okay, so now we've done part B, where we've written a linear function that relates y to x. Our very last step, part C, is that we want to find out how many calories we burn in 4.5 hours. So here's what I'm going to do. I'm going to use that equation that we just got done writing in part B, y equals 300 times x, okay? And I want to find out how many calories that I burn when I kayak 4.5 hours. Okay, so remember, hours is going to be the domain, or x. Okay, so I'm going to substitute 4.5 for x, because that's how many hours that I've kayaked. So what I need to do is 300 times 4.5. When you do that, you should get y equals 1,350. Okay? So what that means is if you kayak for 4.5 hours, you're going to burn 1,350 calories. There's a lot to these types of problems, but if you take it step by step and be careful, you should be able to knock these out no problem. Alright, now here's one, the last one that you're going to try on your own. This is number 3 on page 165. Here's the picture of the graph, or the table, sorry. And you need to do 4 things with this. Number 1, you need to make a graph of this data. Then you need to tell whether or not its domain is discrete or continuous. You have to write a linear function. And then the last part is you need to solve how many calories you're going to burn if you rock climb for 5.5 hours. Alright? So it might take you a minute, but pause the video, get it right, take your time. It's not a race. And then unpause when you're ready to see the answer. Alright, so here's the graph that you should have. You'll notice that all the points on this graph are the ordered pairs in the table. 3 is the x, okay? And you have 1,950 calories burned, so that goes here, almost to 2,000. You had 6 hours and 3,900 calories burned. 9 hours of rock climbing, 5,850 calories burned. And 12 hours of rock climbing, 7,800 calories burned. Alright? Because you've already seen the graph, you should know whether or not this is discrete or continuous. Okay? This is continuous. Do you know the reason why? The reason is because you don't just have to rock climb for 3, 6, 9, and 12 hours. You can rock climb for 2, 1, 10 minutes. Alright? It can be anywhere in between this range. Okay, so this is a continuous domain. The next thing that you needed to do is you need to write a linear function that relates y to x. So remember, the first thing that you need to do when you're trying to write this linear function is you've got to find the slope. All right? So the slope, I'm going to go for find 2 points, the slope between 2 points. I'm going to choose right here because it's easy, and right here. All right? So this point to this point. How far do I have to go up? Okay? 2 lines? Not quite. Is it 2,000? No. Okay? Don't fall for this trick. That line, or that point, is not on that line, right? It's at 1,950, isn't it? So from 0 to get up to this point, I have to go up from 0 to 1,950. So my rise is 1,950. Now my run is how far you have to go across, which is 3. All right? So now to make sure that we have the right slope, let's reduce that by doing 1,950 divided by 3. And when you do that, that will reduce nice and even to 650 over 1, which you won't need the 1. You can just put 650. Okay, that's our slope. Now we need to find the y-intercept. Well, let's look at our graph and find out where this line crosses the y-axis. It crosses right here at 0. So, just like the last problem, our y-intercept is 0. Okay? So to write our equation is going to be y equals 650. I don't need the 1 underneath. It's just saying that it's 650x plus our y-intercept, but I'm not going to write it because I'm not adding anything. I'm just adding the 0 where it crosses, right? So this is my equation right here. Y equals 650 times x. The last thing that we needed to do was find out how many calories you burn in 5.5 hours. 5.5 hours. How many calories do you burn? So to do that, since I know that x stands for hours, I'm going to substitute 5.5 in for 5.5. And I'm going to see what y equals when x is 5.5. I'm going to go ahead and do that multiplication, 650 times 5.5. And your answer that you come up with is 3,575 calories. Okay? So if you were to rock climb for 5.5 hours, you're going to burn 3,575 calories. And with that, that brings us to the end of what I have for you today in this particular video. I will leave you with the joke of the day. I know that you look forward to that. So here it is. What do you call fake spaghetti? An impasta. Alright guys, I hope you guys have a good one. I hope you learned something. Remember, you're loved. Talk to you later.